Hi everyone, today we're looking at one of the early builds of FXGL 25 to be released in September 25, aligned with Java and JavaFX 25. So one of the big things about this release is going to be shaders. So currently what we have is two separate shaders running, or they're actually crashing. So I'll need to fix that. And the idea is that we can do all of this from Java, pure Java. So we're going to store our shaders in Java and then talk to the native layer, but the user doesn't see that. So as far as the user is concerned, they're just operating at Java level, since we don't really want them writing C++ code or GLSL anywhere else. And FXGL's philosophy is basically to be as high level as possible, making sure that everything is isolated, hidden away, and all that kind of stuff. Okay, so currently I'm working on trying to get FXGL properties into the shaders. So shader, well, the ones I'm currently working with are actually just these. So this is an example of a shader in GLSL. And this one just sets the entire thing to red if this is 1, and this will set everything to blue. So we have red and blue shaders. And I probably want this stuff to run not here, but just add a button or something. Okay, so when the button is pressed, I need to position it 100, 150. Compile. Cool. So these two shaders are actually run at the native layer by OpenGL on GPU. Then it's transferred to CPU RAM, from which we get into the Java layer. And then the Java layer puts it into an image view, which has a writable image. And then presumably that goes back to GPU. So it's the usual issue of communicating between GPU and CPU. But it is reasonably easy to achieve. So currently we've got that. And ideally, I am able to then set this something like 1. This is the red value, which is an FXGL property that is easily controllable. And if that talks to shaders on GPU, that's kind of the goal for today. Ultimately, for now, I just need to try all the different use cases and demos. Once all that is working, I'll do the architecture side and then release it to the public so that it's nice and easy to use all of that in an FXGL context. So the FXGL property is basically this. They're backed by JavaFX properties, so we can bind them, we can listen to their changes and the like. But for now, this needs to be inside update somewhere here. What I'm trying to do is map. So we've done the compilation. What I'm trying to do is map the extraction of a pointer to a uniform variable inside the shader. Basically, a pointer to this R value. We can do that using this C++ function. The problem is we're not in C++, or at least not at this layer. So we'll have to downcall this, which we can achieve, I think, with this. So I was in the middle of writing this actually. And just a comment about FFI, it's great compared to JNI, which is the native interface that we used to use before this thing was created. It was a bit of a nightmare actually. But now that we've got this since Java 22, I think it was finalized. This is great. There are a few things that still can be improved, and I'm trying to build a kind of wrapper around it. But ultimately, I have no complaints really. It's great. So we've got the function descriptor going, which is int. This is kind of int, and this address. This is the thing that we're sending. No, this is what we're sending, because that needs to match this. Why don't we just call it the red? Because then it matches. Now that could be quite interesting, because I'm thinking in the sort of client-side usage of this, there could be a thing that creates an automatic link between an FXGL property and a shader variable. Now that would be neat. And then obviously we're going to build the infrastructure in terms of listening for changes. So it takes program ID, which is this, which is what we've got from when we compiled the shaders. And then the property name, which is that. This gives us a pointer, which is int. It has to be int, otherwise this will not know what the type should be, potentially. And then we store it as red. So ID is, okay, so this is ad hoc. This will need fixing later on. But for now, this will be fine. Because what I'm thinking later on, we could have a standalone GL image view or something, which will mimic JavaFX's image view. It might even extend from it so that it has the same basic API. And each such image view is going to have a shader backend, which means you can have multiple shaders in one application. And each of those image views will have its own set of FXGL properties, which are linked directly to shader variables, the uniform variables. I mean, later on, we could even have attribute variables and stuff like that, but for now, uniform is fine. So we've stored the pointer. I think this is the point that we need to get to this, because that's the pointer, right? This is the int. Well, it's actually int. It's not a pointer as a type, but conceptually, it's a pointer. And that's the value. And the signature of this is it returns, I don't think it returns anything, so it's void. Function name, and then it's int. It's probably GLN, but it's type def into an int anyway. And then value, the value is a, oh, we need to do a bit of conversion because FXGL treats everything as a double. Well, it treats any float value as a double, but we need to pass it as a float. So we need a function descriptor. function descriptor of set variable. It's void, it's an int, and that's a float. And then before we render, we need to set the program first. Yeah, so we need to split this up. Where's render? This is render, but we can't have that in one go. This needs to be update frame, and it only needs ID so that we can get the right program. In fact, in the future, this can go away because we can keep track of the program directly. To do pass program directly from Java. In which case, this doesn't need a lot of stuff. Update frame doesn't need the data pixels thing because we don't do anything. Use the program. Then over here, we can down call from Java to set those variables for that frame. And then render frame is what GPU's alternative is for update frame, because that's when it runs its shader. So we need a bunch of calls here. We need another update frame context call. Update frame. The function descriptor of this is, let's do it in place, because it only needs ID of void, and it just takes one thing, I think. Update frame, and it takes integer. Good. So we've called that. Now we can call these, which is context call for each FXGL property. This will be handled by each GL image view. This is what we're calling. This is the function descriptor of it. And then we need to pass this and that. This is the pointer, which is this, which can be obtained by this, red plus ID. And let's get it here. Variable pointer. Let's get, comes back as an int, right? So it will be stored as an int. Get I red plus the ID of the shader. So it'll be red 0, red 1, since we have two shaders. This is an int. This thing gets sent here as an int. And then we need the value, which is float, which needs to be typecast to a float, because we can't send a double. And where does variable, the value comes from here, get double, red. So it's this that I need to remove from ad hoc and then properly implement it. But we don't have a class to store this, so the encapsulation thing is out the window for now. But eventually it'll be there. So this will then actually set So this will be run for each property that we have directly. And then for that frame of the shader, it will set those FXGL properties. Then we get the array, and then we render the frame, and then we render in JavaFX. So there is a lot of steps, which probably will end up being a bottleneck at some point. But in theory, this should work. Let's just check. We need to use that here and then that here. Oh, we also need to actually build our C++ counterpart. Have we done everything necessary? Update frame, render frame. These are split up. Compile shaders returns the program. Okay, cool. That should be fine. It's succeeded. Good. Now we can run this. Hang on. What's happening? Native call failed. Property red 0 doesn't exist. Oh, right. This is... Huh? Property red 0 does not exist. Oh, right. Because we need to compile before we can run this. Because this is on update. A simple Boolean should do the trick. Is compiled false, because when we start, nothing is compiled. Then we click the button, gets to processing. Where does the button finish? Once everything has been done for each shader is compiled is now true. And then if not compiled, skip the update. Cool, so we initialize the shader library. This thing will compile it. And now we have a problem. Property red 0 does not exist. So it's that thing, right? Yeah, so it's that thing that's failing. But why is it failing? Oh, because that's run from a different thread. So is compiled is only true once the whole thing has finished. Shaders for each execute. So that's a separate task because the down call happens on a separate thread. And it's when this has been executed for every shader. Can we just check if the property exists? There'll probably be a workaround. Because then that will signify that the compilation finished. Also, this set is happening from a background thread. So let's just stay on the safe side. Do this on JavaFX, which means there are no threading issues now. And if this thing does not exist, then return. So the is compiled is actually not needed for now. But ultimately, that's actually a good thing to truly know when something has been compiled. So I might add that as a API somewhere once a lot of this is finished. Okay, so if it doesn't exist, then return, which means if it does exist, now I might complain about red 1, but hopefully, yeah. Failed to find function in lookup. GL get uniform location. Oh, because it's probably not in those libraries that I'm looking up in. It's probably in OpenGL 32 lib or something. Well, interestingly, it didn't complain about that one. Oh, it will probably complain about that one because that's the runtime. This is the compile time. GL get uniform location. But luckily, we can just build a wrap around it, which in fact might be even simpler. Let's put that here somewhere. Right, so it needs to return an int. Get uniform var location. It takes an int, which is program ID, and then it takes a const char star, which is a string, and that's the name. And then here we internally call program name, and then we return that as an int. And then let's do the same for the other one. It'll be void get uniform var location. Oh, that's actually what the function is called. But I'll keep the var in there because it helps me understand what is actually retrieving. Get uniform var location, so it's uniform variable, which is that, which is that. So this should now exist in the memory address space for that function. And then set uniform var value, because that doesn't really say anything to me, at least at the Java layer. So how about we rename that to set uniform var value. It's a bit verbose, but at least it means something now. And this is the thing that we're actually calling. And it's int and, in this case, float. So we need, okay, so we need float. Int is the uniform var location, and then float value. We don't return anything, and it's uniform, and then that. Cool. GL uniform. So there's float, there's an int. we can play with that. We can expand that in the future. Int float, cool. This compilation failed. Cannot open for writing. Oh, of course, because we're running it. Succeeded, cool. Set uniform var value float. It's a bit of a mouthful, but I'll do. This is the function descriptor. That's the location. And that's the value. All right, let's do this. Compile. So compilation succeeded. Oh, is it black because it's the value is 0? Let's set it to 1. Now that's brilliant. We now have direct control over shader variables from FXGL properties. Zero, 0.2, 3, 4, 5, 6, 7. That happens real time as well. That's cool. So I'm thinking we can have built-in variables like that for, well, definitely time, because we need to keep track of the time difference between the last frame and current frame, and resolution. That's definitely needed, as well as things like mouse position. And then obviously developers can then build their own shaders and use that to then control everything necessary as part of the application. Now, should be able to do something a bit more complex. So this fragment shader I got from shadertoy.com, which has a lot of fantastic shaders. So we can try that. It needs a bit of tweaking because some things we need to be passed in. But now we have the ability to do that. So how about we do that? Okay, we need to shut this down properly. But just exiting, I guess, because we can't really, we need to have a button to unload shaders, unload everything. Button exit, just put it below, and then set on action. Exit shader library. Cool, that's done. We can now have shader 1, shader 2. They both rely on a thing called uniform float I time. We need that I time passed in from somewhere, from here presumably. But I time, that's going to be a float, so we store it as a double, because in FXGL we don't deal with floats. Everything's a double. If I time doesn't exist, I time 0, I guess, 0. And actually, no, if that doesn't exist or the 1 doesn't exist, this won't be necessary later on once I have the API done. But for now, because we're keeping track of separate variables for each of the shaders, we have to do that. And then once that thing is available here, and we need to update these, fine. It's time. And increment I times 0. No, it's just that. Plus 0066, something like that. We need to retrieve the property name. Here is iTime, and it's also here. And when we set it, we need to get double iTime, but then convert to float. Everything else stays the same. Hopefully. Cool. So we haven't modified C++, so we don't need to compile that. Just run this. Which is great, because then we can just ship the C++ DLL on Windows and different variations of dynamic libraries on other platforms. And then the users should just be able to talk to in pure Java and then use that. That's red. I can't actually modify red, but so compile it. Ooh, that's really cool. And the movement, the animation, is actually handled, well, it's obviously handled by the shader, but the driver for it is Java code and, in fact, an FXGL property. Which is great, because then that means we can take control of pretty much all the variables in the shader, the ones that you do want to control. And then you can pass them in a normal update. Okay, that's brilliant. Right, exit. Okay, so the demo works. That's great. Now I need to sit down, have a think about the architecture of it and how the use case and the kind of calling code would look like. Then hopefully we'll get that done in a commit or two as part of the development build for FXGL. On that note, thanks for watching.